Thank you. Can you hear me? Okay, yeah. Welcome, everybody. Thank you for joining me today. First of all, remember to join the conversation in Twitter, hashtag GOTOCPH, and remember to engage so you can rate my actual session and ask questions. So my name is Ferrer Camacho. I'm an Android developer at Twitter. You can follow me on Twitter too, and ask me questions there too. I work on the Moments team, which is a nice experience, full screen experience, horizontal scrolling, where you can add a list of tweets, and it's a story. It doesn't have to be following a chronological order. For those who are not English native speakers as me, smoke and mirrors is an expression used to describe something that is obscuring or embellishing the truth. It's usually used for magicians because they do magic, which is simply not real. It's just a trick, just so you know. Sorry if I spoil you guys. And the reason for this title was in the last Google I/O during the RecyclerView talk where Adam Powell and Jeet Boyar, Adam Powell actually started the talk by saying, UI developers, we have a lot of things in common with magicians. And that is actually true if you think about some of the animations that we do and some of the components that we use in the framework. And that's the idea of this talk. I'm going to be showing some examples in the Android framework where we are using smoke and mirrors to make an application just great, flawless, and smooth. And after that, I will start talking about one of my favorite apps in Android and how that experience is actually built. And I will do a demo with that. So let's start with the Android framework. So this is a timeline. Hopefully you know what is Twitter. So, theoretically, any timeline can have infinite tweets, right? As you can see, we're scrolling really fast. Performance really good, by the way. So here is the problem, right? The problem is we have infinite amount of views that we want to show, but we have a limitation. We cannot just instantiate thousands of views at the same time. Actually, what we have to really do is we just need to do this. We are showing 1, 2, 3, 4 views in the screen. We don't need to actually show any or instantiate any other view. Just 5 at the same time, 7, 8 tops if the tweets are really small. But Jake likes to talk a lot, so they are just big. So anyway, how we do that? We use this component called RecyclerView. The name will give you a hint of what it's actually doing, which is recycling. I want to talk about it, how internally works, because I think it's really interesting. Internally, it has the linear layer manager, which actually recycles, is responsible for measuring and positioning the item views, and as well as determining when to recycle those views that are not shown anymore. So when you try to actually show the next position, the layer manager is going to go to the recycler view and invoke the method getView for that position. When that's called, the recycler view will go to the adapter and will ask for the type of that view, because you can have many types of views in your recycler view. So for example, if you want to have different headers, or you're going to have a carousel for showing ads, for example. Okay. So yeah, we get the type. The recycler view is going to go to the recycler pool, which is where all the view holders that we can recycle. And it will get a view holder for that type. If there is none, it will go to the adapter and then create one. But if there is one, it would just send it back to the adapter and say, hey, can you bind this view holder with the new data, with the data for that new position that we want to show, the one that was showing on the animation. Once it holds the information, it just returns it back to RecyclerView and then to the layout manager with actually layouts in the screen, that item. This is a really simple explanation of how the RecyclerView actually recycles views. And And you can learn a lot of more in the Google I/O talk that I was talking about, the one that inspired this talk. It's called RecyclerView Ins and Outs, and they talk a lot of more about how to animate items and do transitions in between states. Another example on the Android framework is this one that I'm showing in the Twitter app. As you can see, there is a list of images, and when you click one, we transition to full screen. Those are called shared element transitions. Shared element transitions, they have smoke emitters too. But first, let's dig in on how it works. The way it works is the activity has an activity transition state, which persists the state of that transition, it has the most important part is the shared views that are going to be transitioning to one screen from one screen to another. And then when the activity's life cycle is invoked, for example, it goes to on destroy, or on pause, so it's disappearing. And then we are going to start a new activity. It will call the activity transition state to start a new transition, which will actually call to the activity transition coordinator. The activity transition coordinator, it's a base class. There are actually two. There is the entering and exiting coordinator. So one handles the enter transition and one the exit transition. And that has a transition manager, and it will begin the transition. So by default, the transition is a translation, but you can change that on your theme, and you can actually customize your own transitions between activities. But you will be thinking, okay, you're talking a lot about how this works, but what is the actual smoke emitters in transition in the shared elements? Well, think about it. When an activity is being going to hide or to the background, and another one comes in the top, how they are actually being able to do that transition from one to another? Well, what they do is they hide the target activity, and they have a list of the views that are transitioning from what position they're transitioning, so they pretty much, in a new activity, do that transition. That's what they are doing. And how they do that? Well, they use view overlay, which is used by the default transition in the framework. View overlay provides a transparent layer on the top of a view, to which you can add any type of visual content, view or drawable, and that doesn't affect the layer hierarchy, and it's on the top. So that means that you can pretty much animate anything, and it just works and doesn't mess with the layer hierarchy. It's great. It's going to be your best friend forever in animations. Okay, think about it. That word that I said. So let's imagine this. We have, as you can see, there is two layers. There is the linear layout, which has a nice image view, with a Saturn illustration. And then this is the view overlay. So in order to make an animation, I'm going to add that to the view overlay. How do I do that? Well, linear layout, any view has that. Linear layout, get overlay, and then you add to that overlay. And what is going to happen is that, sadly, that image view is not going to be part of the linear layout anymore. It's going to be in this temporary view overlay that we're going to use for animations. When you do that, the rect of that image view is invalidated in the parent, so that forces a relayout. So you have to be careful if you depend on that view, otherwise you will mess the whole hierarchy. But the good thing is any type of touch event or animation, it gets delegated to that view overlay with that image view. So if you are actually, imagine you have a reference to this image view and you try to do an animation, it will animate even if it's not part of the linear layout anymore, which in this case is part of the view overlay. So, unfortunately, shared element transitions are really nice, but there are limitations. The first one is that the user can't control the transition with the touch. It's just a simple animation from one place to another, so the eye of the user gets caught and doesn't lose the context between the screens. But it doesn't allow the user, for example, to pinch and zoom and control the transition with the pinch and zoom, right? So that's a limitation. And another limitation is that one. Actually, when I was reading the code, I saw that, yeah. The transition doesn't track the target destination. So if you don't eat all the touch events while the transition is running, it looks terrible. And and it's just a limitation. But I mean, we can simply fix that by using this transition listener. Thankfully, we can hear all the life cycle events of the transition. So what we can do is, on transition start, we are just gonna eat all the touch events, pretty much. And then when the transition finishes, we'll just set the touch listener again to the right place. Easy, right? Okay, so before entering into the interesting part of the talk, which is the demo, let's talk about two important attributes for animations. And consistently, these are the attributes that actually mess with all type of rendering outside the parent. So, first of all, is the clip children. The clip children attribute is an attribute of a view group, and by default is set to true, which makes sense, because it clips the children to the bounds of the parent view group, and that's exactly what we want, right? By default, we want that to happen. So it looks like this, right? You are not allowed, that's me, actually. That's my avatar. So I'm not allowed, my image view is not allowed to draw outside the parent view, unless I set clip children to false. And in that case, I'm going to be able to draw outside the first parent, but not the following parent. So what I have to do is, spoiler alert, I have to set that to false in all the parents, which is kind of lame, but that's how it works. So, yeah, okay, really bad animation, but it just shows the point. Okay, so clip padding. So clip padding is the same. So if you have the clip children false, but you have a padding, the view is still going to clip to that padding. Yes, that happens. Especially with RecyclerViews, happens a lot. So just remember, if suddenly a view of yours gets cut in a RecyclerView, maybe it's because there is a padding and you didn't set that to false. So this is what it looks like. It gets clipped to the padding. And, you know, pretty much what I did at some point, I think a long time ago, was creating this type of utility which allows me to go through all the parents of the view and just set everything to false, which is not super difficult. But anyway, let's talk about one of my favorite apps. Yeah, it's Google Photos. Have you think about it? Do you have it? Do you like it? I think before I never had such a great UI experience in a gallery. I was actually, it's just top notch. It's really well thought, and for a long time I was thinking, hey, how did they pull that off? Like, it looks so good. But let's check it out how it works actually. So there is one layer, two layers, and then full screen, right? I'm really bad at pitch to zoom, as you can see that. I'm not really accurate, but anyway. So that's how it works. It's like super smooth. It has 3 levels of zoom, and then it goes to a full screen. And as you can see, they are able, you know, the user is able to control the transition to full screen, which we were saying that share element transition can't do. It's a limitation. Okay, so the way you figure out how something works in the UI, pretty much these developer options. You make them 10 times slower, which is too slow. Maybe five times is fine. And you make the animation 10 times, the duration and the animation scale 10 times slower. And then when you do that, so this is what it looks like. Yeah, the other is just starting. So with that, you are able to see what is going on, because you will understand why that's really important soon. But for now, another developer option that you want to enable is flames. Yes, I like flames. So show layout boundaries. And you should enable it all the time. It's such a beautiful UI right now. It's wonderful for your eyes. No, but really, this is really useful for developers. There is the blue lines, which are the clip bounds. There is the red lines, which is the optical bounds, which is something introduced in 4.3 that I actually didn't have ever to use, but maybe you need it, so check it out. And the ping area, which are the margins. This not only helps to see the alignment in your whole screen, but it will help us to figure out, I did already, but I want to show you if we will do it together, so you see what is the trick of the Google Photos application. So now this application looks like that. It's pretty much the same, but with some layout boundaries, right? Yeah, this is Google I/O. We had such a great time, by the way. Anyway, so now, just pay attention to the video. I'm not going to say anything. Just think yourself how this is happening, and then I will go deeper onto what is really happening. Okay, so I'm pinch and zoom. This is my, yeah, that was the concert. Anyway, so, 3 levels. So I'm scrolling, going back. Are you seeing what is happening? You see? We didn't see that before because it was fast enough, right? And now, yeah, pinch to zoom is more difficult. Once you put it a scale 10x, it's super difficult, actually. You have to do a really huge span in order to go to full screen. So what happened? Did you notice what happened? Okay, let's cut to the real part, which is, okay, this part, they zoom in. But let's get closer. You see that? Can you see the two different recycler views? There is another invisible recycler view with the destination size, with the bigger size, and not only that, but they are actually cross-fading between one and another. It's all smoke and mirrors. They're just tricking us, but that's magic, guys. That's what we do. We do magic. So the lesson here is, sorry, let's put it back. It's really good. Magic. Okay, yeah. So the lesson is anything fast enough will look good enough, and that's true for everything. When you just try 24 hours to make all your animations 10 times slower, and you are going to see how the application suddenly doesn't make any sense anymore because they all actually use that fast transition, fast animation that hides all the problems in the implementation, right? There is one more thing that wasn't able to get on that video, but in this video you will figure it out. When you try to zoom in to the full screen, here we go, what is going on? It's the same image. Right, so they are kind of faking it. They're copying the same drawable maybe, and they are using it in order to do the transition to the full screen. So that's another trick. But if you do it fast enough and the scale is not 10 times slower, then it just works. So that again, more magic. These Google Photos guys are just magicians. So fake it until you make it, pretty much. Fake it until you make it. That's what we just do all the time in under development. And so I show you how it works, but now I tried to be sure that I wasn't doing it wrong. That my assumptions wasn't wrong, so I'm actually created a demo. Well, I created a demo, which is a simplification of Google Photos, but it's pretty much it. It's like 2 zoom levels, and then the last one goes to full screen, and so you can see all the smoke and mirrors, and you can actually see the code. It's going to be in a GitHub repo, so you can check the code, and you can actually apply all those tricks to your applications. So let's go for the demo. Yes, fireworks. So good. Again, okay, fireworks. So this is the application. This is some nice drawings by my wife. It's illustration. It's an illustrator. Yeah, so zoom in, zoom out. Okay, and then full screen. Full screen, full screen. Okay, so how did I implement that? So these are the layers. I have a container, a medium recycler view, a small recycler view, and a full screen container. So the container is going to be the root of the whole hierarchy layout. And of course, it's a frame layout. It's an obvious choice because we need to stack all those layers on the top of each other, and they are going to take full screen. Why do I need to put the full screen container on that screen? It's because, as I said before, the transition, the shared element transition, doesn't allow the user to control the transition to full screen, but I want to do it because that's the nice experience. So I put everything here, and you can just do that by creating your own navigation manager. And depending on the state, you have a stack, and depending on that stack, you can just instantiate the presenters and the view delegates that you need for each of the layers. But let's talk about the important part, which is the medium recycler view and the small recycler view. From now on, I'm going to call the small images the small recycler view, and the medium, which is a terrible word, but I didn't know how to say bigger than small, which medium is fine because it's not too big, so medium is fine. So medium small recycler view will be the higher level of zoom before going to full screen. So we are using to RecyclerView because that's the trick that allow us to do that nice zoom-in effect on the gallery. But before doing that, we have to talk about something. And I'm really bad at pronouncing this word. Nobody actually understands me. So it's pivot or something like that. And otherwise, you have this nice meme from my favorite episode of Friends, which was the pivot. If you don't know it, you may be too young, so you should watch it because it's really fun. It's still fun. Incredible. Still fun. So yeah, let's talk about pivot. So the pivot, by default, it's set in the center of the view. So what happens is when you try to actually scale something, it scales from center, and it goes in all directions. So it looks, that's not what we want, right? What we want is to actually scale right down. So the first thing that we have to do is set the pivot to 0, to the top left point of the view, which is the recycler view, because it's the one that we are scaling. That's important for scaling and rotating too. So then it looks like this, which is actually what we want. We want that type of scale. Okay, so we have two recycler views, and my approach is to use two adapters, but with the same collection backing them up. Because really, they are actually using the same data. It's just the same image. They just have a different size, right? And then it's important to set on the setup the medium one to invisible, because we only want to show one first, which is the small one, which is the one that is going to be zooming in the first time. And then let's talk about touch events. The way there is different approaches, but the approach that I liked was to create this item touch dispatcher, which is a class that gets all the touch events, and depending on the state of the view, we delegate that touch to one or another class. So pretty much what I did was creating this class and then add that class to both adapters. So how does it look like? Well, it looks like this. It has more stuff, but the touch event is probably the most important part. So, since both recycler views are using the same, we can get the ID of the recycler view. So in all the moment, we know what is the recycler view getting the touch event. For that, what we do is we have this gallery gesture detector, which I will talk about it later. It's the scale gesture detector that we will use for scaling the recycler views. And what I do is, in case the small recycler view is getting touched, it means there is only one way, which is it can only go to medium recycler view. It can only zoom in, right? So that's what it's doing. It's pretty much delegate that to the gallery gesture detector, which will know and will do that zooming. Then, in case of the medium recycler view, we have the same. The gallery gesture detector will know how to do it. It has both logics. The important part here, though, is that we have zoom out, which goes from the medium to the small, but we have zoom in, or in this actually I was kind of lazy and I just did click, but when you click, you go to the full screen. And then, so how we do that? Well, we use the span. The span is it's actually not the current span, it's the delta between the last span and the current span. The span is the distance in between your fingers. So with that, if it's 0, I know there is no pinch and zoom in, it's just clicking. And with that, I ask the recycler view, which in this case we know is the medium recycler view, give me the view on that coordinates, and then I just perform a click. So that's how the zoom in, zoom out between a medium recycler view and a small recycler view works. Now, how do we scale them? So this is what we are missing, right? We weren't scaling. We were just setting the touch events, but not scaling, right? For that, we have a convenient contract in a platform on a scale gesture listener. And it has on a scale, on a scale begin and a scale end. The names are pretty self-document, but on a scale begin, you just set up everything for starting the scaling. On a scale is the constant stream of the scale gesture, and on scale end is pretty much the user just stopped touching the screen, so just reset the position to the state that you want. So in the scale begin, what we want to do is show both small and medium recycler view, because what we want to do, as you saw in the video, is at the middle of that zoom in or zoom out, we are going to do a fade in, fade out in between both recycler views, right? So both have to be visible. You can do it different, but this approach works because the smoke and mirrors, it comes at the end on the scale N. But on the on scale, this is pretty much all the maths of the talk, which is, well, there is a gesture tolerance, which applies a low pass filter to avoid the flakiness, because our fingers are, not that accurate. So even if you think you are not moving your fingers, the screen is getting some events. So there is a constant signal that can produce small increments and decrements on the scale. So we want to apply a low pass filter so we know that a minimum span was met, and it's a span on that same direction that we were scaling before. So that's the gesture tolerance. As I was saying, this code is all in the repo, so you can actually read that method later. Then we have the scale factor and the scale factor medium, which are the scale factor. As you can see, on a scale, give us a detector. The detector gives us a scale factor, and we use that scale factor with a clamp function to limit the minimum and the maximum scale of both recycler views. And of course, one is the inverse of the other, and the minimum and maximum, they have to match, otherwise in the middle of the transition, they would not have the same size, and then the fade in, fade out will look terrible, right? Because it will not match. So, the numbers are whatever I like, but you can actually modify that and make it as complex as you want. And then the alpha is the same. We want that alpha to be in the middle of the transition, half for both of the recycler views, and then at the beginning, a small recycler view 1, and the medium to 0, and at the end, the other way around. So that's how the on scale works. But what happens if suddenly the user stops touching in the middle of a transition? If we don't do anything else, if we leave it as it is, it's going to just look like two recycler views and half alpha, both of them, or you don't know, it depends, right? But it will look weird. It will just get on a weird state. So on the scale end, what I want to do to hide this implementation, these smoke emitters, what I want to do is just finish the transition automatically to one of the states. And for that, I just use transition boundary, which transition boundary is just I calculate the delta, and so I know how much is missing for the transition. So if it's below 20 or 30%, and you can change it and put whatever you want, I will assume that the user didn't want to go full screen, and he actually want to go back to the small, right? That's what I do. Otherwise, if it's above that transition boundary, it means, okay, he want to go to full screen, but he was just doing really quick the move. If you don't do that, what happens is like everything just gets stuck in one place, and that's we don't want that, because that will show the trick to the user. So with that, we have the container, the medium recycler view, and the small recycler view. But then let's talk about the full screen image container. The full screen is it's a frame layout with a black background, and that shows in full width the image. So exactly this. So to do that, there is this requirement by the recycler view. When you add an item to the recycler view, the following, so you add one item and then another item. The second item is going to be in a higher elevation than the first one. So if you try to actually scale that first item, it's going to be drawing below the second item. So it will just not look right. Each item has an elevation in a recycler view. So there are different approaches. It's probably the most difficult, which is just create a custom layout manager that knows when we are clicking that item, when we are clicking one single item, we want that item to be on the top of everything and be able to draw above all the other items, which I will not do because that's too much work when you can fake it. Exactly, I like to fake things. So yeah, then you can use this one. This is a middle ground one, which is easy. It's just a callback, and then what you're gonna do is when you get that callback, you set the elevations to the rest of the items. So the item that we want to scale is going to be on the top of all of them. But remember, we talked about it 5 minutes, no, not 5, but 10, 20, I don't even know. At the beginning of the talk, we talk about your best friend forever in animations from now on, view overlay. That's what we can use. We can just use the view overlay on the top of the recycler view for the transition, for the pinch to zoom to the full screen. And then we just add that item, that view, to the frame layout, which is the full screen container. Why you want to make it more complicated when you can do it easily, right? That's it. It's like 5 lines. So how does that work? It's more than 5 lines. There are some methods there and some abstraction, but okay. You get the overlay from the full screen container. You're going to clear the state of that overlay because you don't know if previously maybe another item that was zooming. And then you're going to add the new item. As you can see, this was in on-click. That's the perform click that we were doing before on the item touch dispatcher. Item touch listener dispatcher, yes, that one. And what we're going to do is we animate that item view, and then animate to full screen. And what we have to do is with an end action, which is going to be setting the click listener so we can go back to the gallery, to the medium recycler view. Let's take a look at that method. So that method is actually pretty trivial too. As you can see, of course, there is more things going on, like setting the background to black, setting the background to transparent, or setting the visibility to on. But pretty much the idea is you are just using the overlay to do your transitions. And then at the end of the state, when the transition is done, you add that view to the real parent where we will actually add all the logic to do, if you want to edit that image or you want to change the name of the image or whatever a gallery application does on a full screen image. So what we are going to do when somebody clicks on that item and on that full screen image, again, we just have to transition back to the medium recycler view. So we add that item again on the overlay, and then we are just going to animate it. We're just going to set the origin X, origin Y, and then scale it to 1, which is the default, which is the original size for that image. And finally, don't forget to remove the item from the overlay, otherwise it will just still be there until somebody something in the framework decides to recycle that. And that's it. That's how easy you can allow the user to interact on the transition without using the shared element transition, just by creating layers on the top of it and just one activity. And then you get this. You get zoom in, zoom out, click listener, full screen. I mean, not bad for 20 minutes or 30 minutes of talk. Again, magic, guys. This is all magic. That's what we do. We do UI development. We do magic. That's magician is your new job role from now on. So let's recap. Let's recap. Magic tricks that you can use for animations. Clip padding, clip children to draw over parents and paddings. That's an important one. If you see something is cutting your views, it's probably one of those are not set to false. The view overlay, best friend forever for animations, really. It allows you to draw over the whole layer hierarchy and to do any type of things without messing with it. Share element transition it doesn't allow the user to control the transition without events. So you can actually allow the user to do that by just creating a single activity and then creating your own navigation, which is not, it doesn't have to be super complex. We don't need to have 300 life cycle events or anything like that, which it should be just show, hide, and maybe something like animate to next or enter or exit the screen. But that's a whole idea for another talk. And then finally, fast animations hide any problem with implementation. If you do it fast enough, as we saw during the talk, it's just gonna look right and nice and smooth and good anyway. So remember that, make it fast enough so the eyes are not able to see the trick, which is pretty much what musicians do. And with all of that, thank you. Here is the repo. You can check the code right now, yes. You can ask me questions there too. And if you want more examples of smoke emitters, this great application by Nick Butcher played has many more examples. So remember to rate my session. Thank you.